In this problem, there's a infinitely large pond, which is basically a line. And in this pod, there's a frog that starts at coordinate 0. And from coordinate 0 all the way until coordinate n minus 1, there's a pad that this frog can jump onto. And this frog moves in a weird way. He first moves forward a spaces, then he moves back b spaces, then he moves forward again a spaces, then all the way back b spaces, so on and so forth until he reaches the n minus 1 coordinate. And the misleading thing that is very tricky to catch is that if a frog leaves a pad, he can never ever go back to that coordinate. So, for example, let's say here, right, this frog, the a value is 2 and b is 1. So the frog jumps here, goes back 1, goes forward 2, goes back 1. But he can't go here because he has been to index 2. So that would not be a valid sequence, and you would never be able to reach the n minus 1 coordinate. So due to an audio issue, I've actually solved this, but I'll go over this again. So the first thing to know is, let's just try and think about what happens, right? So it becomes, he starts at 0, then goes forward a, then goes back b, then he goes forward a, then he goes back b, and then so on and so forth. And then to make this even simpler, let's just make some variable called c, right? And let's set that to a minus b, to then become 0, a, c, a plus c, 2, c, a plus 2, c, 3c, so on and so forth. And we know two things. At the very first value has to be 0, and the very last value has to be n minus 1. And if you write it in this form, it's very easy to see that the difference between every other element is c. C minus 0 is c, 2c minus c is c, and like a plus c minus a is c, a plus 2c minus a plus c is c, and so on and so forth. And every other element would link, so like this a, this a plus c, this a plus 2c, all is a coordinate where the frog reaches after he jumps forward a, and this 0, so and this c, 2c, 3c is a coordinate when he reaches, when he jumps backwards, right? So let's just create a sequence, which I'll just call sequence 1 and sequence 2. And sequence 1 is all the coordinates he would reach when he jumps backwards, and sequence 2 is all the coordinates he will reach when he jumps forward, right? So he has to start off at point 0 because that's where he currently is, and he has to end up at point n minus 1. So let's say c equals 1. So that means we'll add a coordinate 1. Let's make it easy by looking at example 1. So n is 5, so it's 4, and then we'd keep on adding numbers to this sequence until this sequence value is less than this value, or unless these two values are equal. Because if we kept this chain going on, they'd both have the pad 2, and you can't jump on a pad twice, because once you jump on it and leave, then it'll go away. So if both of these sequences share a pad, then you stop prior to that. So you'd stop here. So once we get these numbers, how it works is you would start at the lowest value in sequence 1, then you jump to the lowest value in sequence 2, which is a 3, and then you pop the 0. So once you pop the 0, now from this you jump to the lowest value in sequence 1, which is going to be the 1, and then you pop where you were just at, this 3. And then from 1 you jump to the lowest value in sequence 2, and that's the 4. So you go from 0 to 1 to 2 to 0, and that's a valid sequence, which is also the answer to this problem. Well, to this input, right? So that's what happens when they both match at a certain index. So they both share a pad. So let's assume they both don't share a pad, right? So if it is, so let's make this, let's put C as 2, and let's make n as 6. So n minus 1 would be 5. So then this would be 2, this would be 3, and then would this work? So you would go from 0, okay, the two indices, right? So 0, 1, 2, 3, 4, 5. You would jump from 0 to 3 to 2 to 5. That this sequence works fine, and it also works A, B, A. But if we keep on going, right, such that this now becomes 1 and this becomes 4, they both are paths in the sequence that have not been touched, but this won't work. Why? Because you jump from 0 to 1, but sequence 2 is always when you jump forward, right? And sequence 1 is when you jump backwards. And you can't jump backwards from 1 to 2, right? So that creates an error. So you always have to ensure that the lowest value in sequence 2 has to be higher than this value, which is going to be C, right? So those are the two edge cases that you have to think about. So here you read in the input, you get in the array A, and then the answer can be a long because it can go up to a magnitude of 10 to the 14, right? So we keep track of the answer, so LL answer, and then the value of C has to be bigger than or equal to 1. Why is that? So let's say the value of C is 0, right? That means you would go forward, for example, 2, but then since C is 0, B is also 0, so you'd go back 2. But since you jumped off this pad, you are basically jumping into the water, and that is invalid. And if the value of C was less than 0, you're going backwards, right? Because your B value is higher than your A, so that means you would like jump forward 2, but then you go back 7, jump forward 2, go back 7, and you'll never ever reach this pad. So that's why the value of C has to be 1 or larger. And so then for each value of C, you'll keep track of the current sum. You start from the left at index 0, you start from the right at index r minus 1. And then here, the two things you check for, r is bigger than the second value, which is C, which I call in this loop I. So r is bigger than I, and visited r does not equal I. So what is the point of this? So if you remember before, we had, when we had this, the issue was when there were both 2's, right? So the way to get over this is, after we increment our left index and our right index, then we're checking what the future left index is, and if the future left index is the same as our future right index, then we say stop, right? So an easier way to understand this than do this loop actually would just simply be just say here, if L equals if visited, would that work? They don't actually have to meet at the same point. There is a possibility that they meet elsewhere. So we have to check that we haven't seen visited L before in this version of C. So this should not equal, so if this ever equals I, or visited R equals I, then we should just break. So why is this? So we only set I, which is our, okay, I'm now going to call this IC because that's basically the C value here. So We only give the value c to some index in this array if we have been there. So once we have been there, we set that value to our current c value, and then we check. So then we increment L and R, and then we look and check if our future left index or our future R index has been seen before. If it has been seen before, then we just don't go there, because then we know we are in a problem like this. So that's basically what the point of that was. So yeah, you just keep track. You just add the value of the left and the right. You just check if that leads to a maximum answer. If it does, you update answer. Then after you do that, you just increment L by I, you decrement R by I, and then you keep on doing that until it's valid. You do that for all C, and that's how you find the maximum answer. And with the code, if you comment all the things I changed, it works. So voila.